Most people over 60 don't realize that every single year, they're quietly losing muscle, even if they think they're eating well, staying moderately active, and getting their protein. The truth is sobering. Starting around the sixth decade of life, the body begins a slow decline in muscle mass, a condition known as sarcopenia. It's not just about losing muscle size, it's about losing strength, stability, and the metabolic machinery that keeps you energetic and independent. It's that subtle weakness you feel when standing up from a chair, the slower pace when climbing stairs, or the extra effort it takes to carry groceries. Most assume it's just purging, but in reality, it's a biological process that can be slowed and even reversed when we understand the deeper science behind protein and muscle preservation. Here's the shocking part. Even those who eat plenty of protein, who have eggs every morning or chicken with dinner, are still losing muscle. Why? Because not all proteins are created equal, especially when it comes to stimulating muscle protein synthesis in older adults. The body's ability to process and use amino acids declines with age, meaning that the same protein that once maintained your muscles at 30 might not be enough or effective at 60. It's not about how much protein you eat, but the S type of protein and how efficiently your body can absorb and use it. For decades, eggs have been celebrated as the gold standard of protein. They're convenient, packed with essential amino acids, and often used as a reference point for protein quality. But what if that reputation is misleading? What if the idea that eggs are the perfect muscle food isn't the whole story? New nutritional research is uncovering that one specific vegetable, yes, a vegetable, contains a more balanced amino acid profile that actually supports muscle recovery and synthesis better than eggs for aging adults. It's not about replacing eggs completely. It's about recognizing that certain plant-based proteins can perform just as well, if not better, especially when it comes to longevity and inflammation control. It sounds counterintuitive. How could a plant source, something we usually think of as light or complete, rival one of nature's most protein-rich foods? The answer lies in how the body metabolizes and uses those amino acids. Some vegetables, particularly those in the legume or cruciferous families, contain compounds that enhance muscle recovery by improving mitochondrial function and reducing oxidative stress. They don't just feed the muscles, they protect them. And this matters because muscle health isn't just about appearance or strength. It's one of the most powerful predictors of how well you'll age. Think about what muscle really represents. It's not just tissue, it's vitality, it's your ability to move, to balance, to metabolize nutrients efficiently. When muscle mass drops, everything changes, energy levels fall, glucose control weakens, and even cognitive health starts to decline. That's why maintaining muscle isn't simply about vanity or performance, it's about preserving your independence. Losing muscle means losing the ability to live freely, to pick up your grandchild, to travel without fatigue, to enjoy your favorite hobbies without pain or hesitation. Now imagine that the solution isn't found in a carton of eggs, a protein shake, or a supplement powder, but in something growing in your garden or sitting in the produce aisle. A humble vegetable that can outperform eggs in supporting lean muscle tissue, enhance amino acid availability, and help keep inflammation. One of the key drivers of aging, under control. The science behind this discovery challenges long-standing dietary assumptions and opens the door to a more sustainable and effective way to age strong. This is the moment where the question becomes impossible to ignore. What if what we've been told about protein is only half the story? For years, the conversation around muscle health and aging has focused on quantity. Get more protein, eat more meat, have more eggs. But the real secret lies in quality and bioavailability. The older body doesn't just need protein, it needs the right kind of protein, one that optimizes mTOR signaling, supports mitochondrial repair, and helps regenerate muscle fibers efficiently. And here's where this overlooked vegetable becomes fascinating. It provides a rich source of leucine, the amino acid that triggers muscle building, along with plant compounds that protect muscle cells from oxidative damage. Unlike some animal proteins that increase inflammatory markers or strain the gut microbiome, this plant-based protein supports both muscle growth and longevity simultaneously. It's protein that works with your body's aging systems, not against them. Picture waking up feeling lighter, stronger, and more stable, not because of a new workout trend or expensive supplement, but because of a simple change in what's on your plate. The science of aging is changing, and it's teaching us that muscle health is about more than macros and calories. It's about cellular resilience and metabolic balance. Every bite we take either supports or sabotages that process. For those over 60, this revelation is empowering. It means that the decline isn't inevitable. It means that strength, mobility, and vitality can be preserved, even restored, through informed nutrition choices. Eggs have their place, yes, but there's a better story unfolding in the plant kingdom, one that's rewriting how we think about protein, aging, and the future of strength. The question now isn't whether muscle loss can be stopped, but whether you're ready to rethink what true, age-defying nutrition looks like. Sarcopenia is the silent epidemic of aging, a gradual and often unnoticed loss of muscle mass and strength that begins in middle age and accelerates after 60. It's not simply about shrinking muscles or lower physical performance, it's a metabolic shift that affects everything from balance and mobility to glucose regulation and energy production. When muscle begins to waste away, the body loses one of its most powerful tools for maintaining vitality. This process is driven by a complex interplay of hormonal decline, chronic inflammation, and mitochondrial inefficiency, all of which make the muscles less responsive to protein and exercise stimuli than they were decades earlier. Around the age of 60, several biological systems begin to change in ways that directly impact muscle synthesis. Hormones such as testosterone, estrogen, and growth hormone decline, reducing the body's anabolic drive, its ability to build and maintain tissue. At the same time, chronic low-grade inflammation, known as inflammaging, interferes with the cellular processes that repair muscle fibers. The mitochondria, often referred to as the powerhouses of the cell, start producing less energy and more free radicals, creating an environment where muscle regeneration becomes sluggish and inefficient. The combination of these factors leads to anabolic resistance, a state where the body simply stops responding to the same amount of protein and exercise that once maintained muscle with ease. This is why so many older adults feel that they're doing everything right, eating protein-rich meals, walking daily, even lifting light weights, yet still losing muscle strength year after year. The problem isn't necessarily effort, it's biology. As the body ages, it requires a more strategic approach to nutrition and activity to trigger the same muscle-building signals. One of the most important concepts in this process is the leucine threshold. Leucine is a branched-chain amino acid that acts as a signal for muscle protein synthesis. In younger individuals, small doses of leucine-rich foods like eggs or meat easily activate this process. But in older adults, the muscle cells become less sensitive, requiring higher amounts of leucine and a more concentrated pulse of amino acids to achieve the same effect. This is where timing becomes critical. In younger years, the body can efficiently build muscle throughout the day, even with scattered protein intake. But after 60, muscle protein synthesis is highly dependent on consuming adequate amounts of high-quality protein within a defined window, ideally around physical activity when muscle cells are more receptive. Consuming smaller portions of protein throughout the day without hitting that leucine threshold at any one time often leads to a blunted anabolic response. Essentially, many older adults eat enough protein in total, but never enough at once to trigger true muscle repair and growth. Animal proteins, such as eggs, have long been considered ideal because they contain all the essential amino acids, including leucine. However, while eggs do offer these building blocks, their anabolic potential in older adults isn't as robust as once believed. This is partly because of how the body processes them. Aging slows digestion and reduces amino acid absorption rates. The result is a slower, weaker spike in blood amino acid levels, not enough to fully stimulate muscle synthesis. Meanwhile, other nutrient factors that support protein metabolism, like vitamin D, omega-3 fatty acids, and certain antioxidants, are often missing or deficient, further limiting the body's capacity to rebuild tissue efficiently. Inflammation compounds the problem. Chronic low-grade inflammation, often driven by poor diet, inactivity, or oxidative stress, interferes with the mTOR signaling pathway, the molecular switch that turns on muscle growth. When this pathway is suppressed, even a protein-rich meal can fail to elicit a meaningful response. This is why quality matters just as much as quantity. Certain plant-based proteins, for example, come packaged with anti-inflammatory compounds like polyphenols and flavonoids that support mitochondrial health and reduce oxidative stress. This synergy enhances muscle function in ways that isolated animal proteins often can't. Lifestyle plays a defining role in how effectively the body can utilize protein for muscle repair. Inactivity accelerates sarcopenia more than any other single factor. Without regular resistance or weight-bearing exercise, the muscle fibers simply don't receive the mechanical signal needed to initiate synthesis, no matter how much protein is consumed. Poor recovery, insufficient sleep, and chronic stress also inhibit anabolic processes. Muscle regeneration happens primarily during deep sleep when growth hormone is released, so disrupted sleep patterns directly undermine muscle health. Likewise, cortisol, the stress hormone, promotes catabolism, the breakdown of muscle tissue. Then there's the question of nutrient synergy, how various vitamins, minerals, and phytochemicals interact to support muscle metabolism. Traditional animal protein sources like eggs or dairy may lack the full complement of these supporting nutrients. Certain plant-based sources, in contrast, come naturally paired with antioxidants, magnesium, and bioactive compounds that support mitochondrial repair and reduce the oxidative burden that drives sarcopenia. When older adults diversify their protein sources to include these nutrient-dense vegetables or legumes, they create a biochemical environment more conducive to muscle preservation and recovery. Understanding the science of sarcopenia is empowering because it shows that muscle loss is not an unavoidable consequence of aging. It's a response to biological and lifestyle shifts that can be countered through intentional action. By focusing not just on eating protein, but on how and when it's consumed, older adults can overcome anabolic resistance. Pairing higher leucine foods with anti-inflammatory nutrients, Aligning protein intake with activity and maintaining mitochondrial health all work synergistically to reignite the muscle, building machinery that slows with age. It's not simply about eating more. It's about eating smarter. The goal is to restore the body's sensitivity to protein, to make every gram count. By understanding the timing, quality, and metabolic context of protein intake, individuals over 60 can reclaim strength, improve energy, and slow the physical decline that too many accept as just getting old. The science makes it clear aging doesn't have to mean losing power. It just means learning how to work with your body's new biology, not against it. The vegetable that challenges the long-standing myth of eggs as the ultimate protein source is spinach, one of the most nutrient-dense, bioactive, and muscle-supportive foods nature provides. Spinach isn't typically thought of as a protein food, yet its amino acid composition and cellular impact make it extraordinary for aging adults. What makes spinach truly unique is not just its protein content per se, but its quality. How efficiently those amino acids are used by the body, how they interact with mitochondria, and how they reduce the chronic inflammation that blunts muscle synthesis after 60. In essence, spinach provides a cleaner, more biologically harmonious form of protein that supports muscle strength, longevity, and metabolic health in ways traditional animal proteins simply can't. When we look closely at spinach, its amino acid profile reveals something fascinating. It contains all 9 essential amino acids, including leucine, isoleucine, and valine, in ratios that closely resemble those needed for human muscle protein synthesis. While its absolute protein quantity per gram may be lower than that of eggs, the bioavailability and supporting nutrient matrix make its protein more efficiently utilized at the cellular level. This is because spinach doesn't act in isolation. It delivers a cocktail of cofactors, magnesium, iron, potassium nitrates, and chlorophyll that collectively enhance mitochondrial efficiency and muscle oxygenation. Magnesium, for instance, is a critical cofactor in ATP production and muscle contraction, while nitrates improve blood flow and nutrient delivery to muscle tissue, amplifying the effects of resistance training and recovery. Spinach's role in muscle health extends far beyond amino acids. One of the reasons older adults experience anabolic resistance is due to mitochondrial decline. The energy-producing organelles in muscle cells become less efficient and generate more free radicals. These reactive molecules damage proteins, lipids, and DNA, impairing the very systems that sustain muscle integrity. Spinach's rich supply of antioxidants, including lutein, zeaxanthin, and beta-carotene, helps neutralize this oxidative stress. Moreover, compounds like quercetin and camphorol found in spinach activate pathways that enhance mitochondrial biogenesis, the creation of new mitochondria, effectively rejuvenating the cell's energy systems. This is essential for preserving lean muscle and preventing the fatigue that often accompanies aging. Another powerful element of spinach lies in its anti-inflammatory properties. Chronic inflammation is one of the primary reasons muscle synthesis slows after 60. It interferes with the mTOR pathway, the central regulator of muscle growth, and increases muscle protein breakdown through cytokine activation. Spinach is naturally rich in alpha-linolenic acids, a plant-based omega-3, and unique polyphenols that suppress these inflammatory cytokines. By reducing inflammation, spinach helps unblock the muscle-building process that often remains dormant in older adults despite adequate protein intake. It's a nutrient synergy that animal proteins, including eggs, typically lack. This is where spinach's cleaner anabolic response stands out. While animal proteins activate the mTOR pathway effectively, they can simultaneously increase oxidative load and insulin spikes, leading to inflammation and accelerated aging when consumed excessively. Spinach, on the other hand, stimulates the same muscle synthesis pathway through leucine and fat nutrient activation, but without the collateral oxidative stress. It's an anabolic signal that promotes muscle growth in balance with longevity, supporting regeneration without overtaxing the metabolic system. Emerging studies have reinforced this plant-based advantage. In a 2020 clinical trial published in Nutrients, older adults who consumed nitrate-rich vegetables like spinach daily experienced improved muscle strength and power over a 12-week period independent of exercise level. Researchers observed enhanced mitochondrial efficiency and a greater capacity for oxygen use in skeletal muscle. Another study in the Journal of Nutrition showed that plant-based eaters who included spinach and other leafy greens had higher muscle retention over time compared to those relying predominantly on animal protein sources. The mechanism, researchers concluded, was linked to better insulin sensitivity, lower inflammation, and improved amino acid utilization. This brings us to another crucial benefit of spinach: its influence on the gut microbiome. As people age, the diversity of gut bacteria often declines, leading to poor nutrient absorption, inflammation, and metabolic dysregulation. The phytonutrients and soluble fibers in spinach feed beneficial gut bacteria that produce short-chain fatty acids, SCFAs, like butyrate. These compounds not only support gut health, but also play a direct role in muscle metabolism. Butyrate has been shown to enhance muscle repair and reduce muscle atrophy by modulating inflammatory gene expression and mitochondrial function. In contrast, animal proteins, particularly when overconsumed, can shift the gut microbiome toward pro-inflammatory species that release endotoxins and worsen metabolic health. Another underappreciated aspect of spinach's muscle protective power is its effect on insulin sensitivity. With aging, muscle tissue becomes less responsive to insulin, leading to reduced glucose uptake and impaired protein synthesis. Spinach contains compounds such as thylakoids and carotenoids that improve insulin signaling pathways. When insulin sensitivity improves, amino acids are more effectively shuttled into muscle cells, supporting repair and growth. This dual benefit, improved nutrient delivery and reduced inflammation, makes spinach an optimal food for reversing sarcopenia at its root cause. From a metabolic standpoint, spinach can also help regulate body composition. Its low calorie density combined with high nutrient content supports fat metabolism while preserving lean tissue. The nitrates in spinach enhance mitochondrial efficiency, which increases resting metabolic rate, essentially helping the body burn more energy while maintaining strength. Over time, this metabolic rebalancing contributes to better endurance, more stable energy levels, and improved resilience during physical activity. Compared to eggs, spinach offers a more holistic approach to protein and muscle health. Eggs deliver amino acids but little in the way of phytonutrients or antioxidants. They provide protein but can also increase postprandial oxidative stress and inflammation, particularly when fried or consumed in excess. Spinach, by contrast, nourishes the entire system, supporting not just muscle tissue but the cellular environment that allows that tissue to thrive. Its combination of leucine, polyphenols, nitrates, and micronutrients works together to create the ideal biological state for muscle regeneration, metabolic balance, and longevity. This is why the idea of protein quality must evolve. The true measure of protein isn't only in grams per serving, it's in how well it integrates with human biology, how it supports mitochondrial renewal, and how it reduces the aging burden on the body. Spinach represents that evolution of food that doesn't just build muscle but restores the foundation of health that allows muscles to endure. For those over 60, incorporating this simple green powerhouse into daily meals can transform how the body ages, keeping it stronger, leaner, and more metabolically alive for decades to come. Nutrition is a critical piece of the puzzle when it comes to reversing muscle loss after 60, but it's only one pillar in a larger system of biological synergy. The truth is, muscle health doesn't exist in isolation. It's deeply intertwined with movement, sleep, micronutrient status, and cellular recovery. Each of these elements works together, and when aligned, they can not only slow the progression of sarcopenia but actually reverse it. The body, even in later decades of life, retains a remarkable capacity to rebuild strength when the right signals are sent at the right time. The key lies in combining nutrition, such as the amino acid power of spinach, with resistance exercise, restorative sleep, and essential nutrients that optimize mitochondrial function and protein synthesis. Resistance exercise acts as the spark that ignites muscle renewal. Without it, even the best diet or supplementation plan falls short. Muscle tissue is highly responsive to mechanical tension, the stretching and contracting that occur during lifting, pushing, or pulling. These movements activate intracellular pathways, especially mTOR, the master regulator of muscle growth. When resistance training and proper nutrition occur together, the body amplifies muscle protein synthesis far beyond what either could achieve alone. This is especially true for older adults whose muscles are more resistant to anabolic signals. Even short, consistent bouts of strength work, like bodyweight squats, resistance band exercises, or light dumbbell routines, can dramatically improve muscle function when paired with nutrient timing and adequate recovery. Spinach's amino acid profile enhances this process, providing leucine and other essential building blocks at the cellular level. However, for the muscle-building machinery to run efficiently, it requires specific micronutrients that act as cofactors. Magnesium, for instance, is indispensable for ATP production, the energy currency that powers every contraction, repair, and synthesis process in muscle cells. Without magnesium, the energy from food can't be effectively converted into usable cellular power. It's also involved in stabilizing ribosomes, the structures that assemble new muscle proteins. Older adults often have depleted magnesium levels due to reduced absorption, yet this deficiency can be easily corrected with magnesium-rich foods or supplementation, leading to immediate improvements in muscle function and recovery. Vitamin D is another silent force in muscle health. It's more than just a nutrient. It's a hormone that influences gene expression related to muscle fiber repair and calcium regulation. Low vitamin D levels are strongly associated with weakness, poor balance, and a higher risk of falls. When vitamin D levels are adequate, muscle cells are more responsive to anabolic stimuli, meaning they react better to both protein and exercise. Morning sunlight exposure is the simplest and most natural way to restore vitamin D balance. 10 to 15 minutes of unfiltered sunlight on the skin signals the body to produce this vital compound, while also setting the circadian rhythm, improving sleep quality, mood, and recovery cycles. Omega-3 fatty acids, particularly EPA and DHA, play an equally powerful role. These fats integrate into cell membranes, making them more fluid and efficient in transmitting signals for growth and repair. They also suppress inflammation that otherwise interferes with muscle synthesis. When combined with the phytonutrients found in spinach, omega-3s create an anti-inflammatory environment where the mTOR pathway can function optimally without being blocked by cytokine stress. In clinical trials, older adults who supplemented with omega-3s experienced greater muscle mass gains from resistance training compared to those who didn't, demonstrating how nutrition and movement magnify each other's effects. Hydration, often overlooked, is another critical component of muscle function. Every contraction, every chemical reaction inside the muscle cell depends on water balance. Dehydration, even mild, reduces muscle endurance and slows nutrient transport, including hydrating foods like spinach, cucumbers, and citrus, along with steady water intake throughout the day, ensures that amino acids and electrolytes reach muscle cells efficiently. Adequate hydration also supports joint health and recovery, making physical activity safer and more sustainable for older adults. Sleep ties all these elements together. During deep sleep stages, growth hormone surges, driving tissue repair and muscle regeneration. If sleep is fragmented or insufficient, anabolic hormones like testosterone and IGF-1 drop, while cortisol, the muscle-wasting stress hormone, rises. Quality sleep is not simply about duration, but about creating consistency and supporting circadian rhythms through exposure to natural light during the day and darkness at night. Pairing an early evening meal rich in magnesium, leafy greens, and omega-3s can further promote relaxation and restorative rest. Aging muscles thrive on routine, small, sustainable actions that consistently send the message grow, repair, strengthen. The synergy of lifestyle choices is what transforms that message into results. A simple morning ritual could include 10 minutes of sunlight, a glass of water with a pinch of electrolytes, and a breakfast incorporating spinach and a clean protein source. Later in the day, a brief resistance session, even just 15 minutes of controlled movement, can trigger MTO or activation. Follow that with a nutrient-dense mealtime within an hour post-exercise to maximize amino acid uptake. Over time, these micro-habits accumulate into profound physiological change. The anti-inflammatory dietary pattern complements all of this. Reducing processed foods, sugars, and pro-inflammatory oils helps maintain insulin sensitivity and metabolic balance. In contrast, incorporating foods rich in antioxidants, spinach, berries, turmeric, and green tea enhances cellular resilience. This balance supports mitochondrial repair, reduces oxidative stress, and keeps energy metabolism youthful. Each nutrient, each behavior feeds into the next, creating a feedback loop of vitality. When this system is in harmony, the body begins to reverse sarcopenia naturally. Strength returns gradually, balance improves, and energy stabilizes. The once familiar fatigue and weakness that many associate with aging give way to renewed capability. Muscles regain their ability to respond, not because of a single supplement or food, but because the internal environment has shifted toward growth rather than decay. The combination of amino acids from spinach, energy from magnesium, hormonal support from vitamin D, and cellular protection from omega-3s represents the biochemical foundation of this transformation. What makes this approach remarkable is that it doesn't rely on radical interventions or medications. It's built on understanding how the body truly functions, that the same principles that fostered strength in youth still apply, but now require greater intentionality. Nutrition feeds the muscle, movement signals its use, sleep restores its structure, and micronutrients fuel its engines. Together, they form a biological orchestra tuned toward regeneration. Aging doesn't have to mean decline. It can mean adaptation, and when these elements are combined daily, the body's capacity for renewal becomes visible. Strength returns, not by fighting age, but by aligning with the natural science of how we are meant to thrive. Muscle is far more than just tissue. It's a living, dynamic organ that influences nearly every aspect of health, from brain function to metabolism. After 60, maintaining lean muscle becomes one of the strongest predictors of how long and how well we live. It's not simply about staying mobile or avoiding frailty. Muscle is the body's longevity engine. It stabilizes blood sugar, protects joints, fuels the brain with vital energy, and keeps inflammation in check. When muscle strength fades, the entire system begins to weaken. But when it's preserved or rebuilt through the right combination of nutrition, movement, and recovery, it becomes the foundation for independence and resilience well into later life. Strong muscles mean a strong metabolism. Skeletal muscle is the primary site for glucose disposal, acting like a sponge that absorbs blood sugar after meals. When muscle mass decreases, the body loses one of its most effective tools for controlling insulin and blood glucose. This is one reason why sarcopenia and type 2 diabetes so often appear together in older adults. But the reverse is also true. Restoring muscle mass through resistance training and targeted nutrition dramatically improves glucose sensitivity. Muscles act as metabolic guardians, buffering against energy crashes, weight gain, and insulin resistance. They help maintain steady energy throughout the day, which translates into mental clarity, mood stability, and sustained vitality. Joint health and balance also depend on muscular strength. The decline in coordination or stability that leads to falls and fractures in older adults isn't inevitable. It's a symptom of underused, undernourished muscles. When the quadriceps, glutes, and core lose strength, every step becomes less stable, every motion riskier. Yet, studies consistently show that even short bouts of strength training can restore stability and improve bone density, reducing fracture risk by up to 40%. Strong muscles act as shock absorbers, protecting joints and maintaining posture. Combined with anti-inflammatory foods like spinach, turmeric, and omega-3s, this creates a body that moves with ease and confidence, free from the chronic pain and stiffness that too often accompany aging. The benefits of maintaining muscle go beyond the body. They extend to the brain. Research has shown a powerful link between muscle strength and cognitive performance. Muscle contractions release myokines, signaling molecules that cross the blood-brain barrier and stimulate neuroplasticity, the brain's ability to form new connections. These same myokines enhance blood flow to the brain, improve memory, and may protect against neurodegenerative diseases like Alzheimer's. Movement, fueled by strong muscles, literally nourishes the brain with oxygen and nutrients, creating a feedback loop between physical and mental vitality. It's why physically strong older adults often display sharper cognition, faster reaction times, and better emotional regulation. The phrase healthy body, healthy mind isn't just philosophical, it's biochemical. The path to longevity, then, isn't about simply extending the number of years we live. It's about extending the number of strong years, the years of independence, purpose, and energy. Longevity without strength is survival. Longevity with strength is freedom. And that freedom depends on the daily choices that support the body's regenerative systems. The outdated idea that aging automatically means decline is being rewritten by science. Even at 70 or 80, muscle fibers can grow, mitochondria can multiply, and metabolic function can improve when given the right signals: high-quality protein, consistent resistance exercise, deep sleep, and nutrient diversity. This brings us to a new understanding of protein wisdom. For decades, the conversation has focused narrowly on quantity, grams per meal, total intake, and animal versus plant protein debates. But longevity isn't built on numbers alone, it's built on synergy. The body doesn't just need protein, it needs a network of nutrients that work together to reduce inflammation, enhance mitochondrial function, and optimize amino acid utilization. Spinach, for example, provides not only complete amino acids, but also antioxidants, magnesium, nitrates, and phytonutrients that keep muscle cells young and efficient. When combined with omega-3 fats, vitamin D, and regular movement, this synergy triggers muscle regeneration at a cellular level. Cleaner, more sustainable, and more in tune with the biology of aging than heavy reliance on animal protein alone. This isn't about rejecting animal foods entirely, but about evolving the approach from protein obsession to nutrient intelligence. Eggs and meats have their place, but relying on them exclusively can burden the body with oxidative stress and inflammatory byproducts. The real key to lifelong strength is diversity. A diet that includes plant proteins, leafy greens, legumes, seeds, and anti-inflammatory compounds. This combination fuels the microbiome, balances hormones, and supports cellular repair, creating the internal environment where strength can flourish naturally. Science now shows that people who follow plant-forward, anti-inflammatory diets not only maintain more muscle mass as they age, but also experience lower rates of chronic disease and cognitive decline. Consistency is the bridge between science and transformation. The body doesn't rebuild overnight, it responds to signals repeated over time. Every nutrient-dense meal, every 20-minute strength session, every full night of restorative sleep compounds into resilience. The mitochondria adapt, the muscle fibers thicken, and energy levels rise. The process is subtle at first, standing taller, moving faster, feeling steadier, but it represents something profound: biological renewal. The human body, even in its later decades, is still wired for growth when given the right environment. Reversing muscle loss after 60 isn't a miracle, it's physiology working as intended. The same mechanisms that build strength in youth are still present, just quieter, waiting to be reactivated. The moment nutrition, movement, and recovery align, those systems wake up. Muscles begin to respond again, balance improves, metabolism steadies, and the mind sharpens. The body remembers how to be strong. Longevity is not the absence of aging, but the mastery of it, learning how to feed, move, and restore the body in ways that honor its changing needs. The science is clear: strength protects life. It protects the brain, the heart, the bones, and the freedom to live fully. The good news is that it's never too late. Whether you're 60, 70, or beyond, the capacity to rebuild is still there, waiting for the right inputs: nutrient synergy, resistance, recovery, and purpose. When those come together, aging stops being a story of loss and becomes a story of renewal. The body doesn't just survive time, it thrives through it, strong, sharp, and full of life.